Good morning, class. My name is Ndakwo. I'll be taking you Maths 111. This course will be taken by 7 lecturers. And individual lecturers will come and speak to you on various topics, because the topics have been shared. We have about 14 topics, so each lecturer have at least one or two topics to discuss with you. So I'll be handling set theory. What is set? A set is a collection of well-defined objects. Sets are often specified with curly braces notation. Method of describing set. A set membership symbol. The symbol is here. Here's how to write the symbol. Membership is used to say that an object is a member of a set. If you cross the membership, that means it's not a member of. It is red, which is used to say an object is not in the set. Then we have the roster method. The most elementary method of describing a set is by listing its members. Example, you have A is equals to 1, 2, 3, 4, up to 10. You are listing a member of a set. Set builder notation is another method of describing set. The set builder notation or rule method is a method of specifying a set by writing rather than listing the elements. Just like a short form, you are trying to shorten the listing of A. This A here, you have 1, 2, 3, 4 up to 10. You list a member. We want to have a shortcut. You say, okay, X such that, or look at it here, X slash X, or we can say X dot dot X is read as X such that. It's okay. And example 1, A is equals to X such that X are counting number from 1 to 10. Just like this example here. Example 1, A is equals to 1, 2, 3, 4 up to 10. Empty set, that's types of set. An empty set, these are sets containing no objects at all, no elements at all, and is denoted by an empty curly braces. Or you have this symbol here, 0, and you cross it. That's an empty set. Equal set. We say two sets are equal if if they have exactly the same members. Two sets are equal if they have exactly the same members. Example, if A is equals to 1, 2, 3 and B is equals to 2, 3, 1, the arrangement does not matter. But if they contain the same number of elements, the same type of elements, we say these elements are equal. So we say that A is same thing as B. Then we have universal set. I term this set as a bigger set. It's a collection of sets or of theoretical computations. It's a set of all possible objects. All possible objects. Disjoint set. Two sets are said to be disjoint if the intersection is completely empty. That is, no element in common at all. So sets that have no common common elements. Cardinality of a set. The cardinality of a set is its size. We're talking about size here. For a final set, the cardinality of a set is the number of members it contains. In symbolic notation, the size of a set A is written as this, backslash A. A is inside backslash, double backslash. The subsets for two sets A and B are said to be a subset if each member or each element of A is also an element of B. In formal notation, we have A is a subset of B if for all X is a member of A, or X is a member of B. And if A is not a subset of B, we also say that B contains what? B contains A, which can be written as this. You can see there. And if A is not equal to B, then we write A is a subset of B. We say that A is a proper subset of B. For example, if A is equal to ABC, then A has 8 different subsets. We have empty set, we have set A, we have set B, we have set C, then we have A and B, we have A and C, you have B, C, then we have A, B, C. Power sets. Now the types of set. Power set is a set of all possible subsets of set X, denoted by P of S. Power set of S. So, for example, you have the power set of 0, 1, 2. What you do is you take all the possible subsets of this value here, this set 0, 1, 2. All possible subsets with a cardinality of 2 raised to power n. N is the number of the elements here. How many numbers are here? 1, 2, 3. So n is 3. So 2 raised to power 3 gives you 8. So you are supposed to have 8 sets. If you count here, 1, 2, 3, 4, 5, 6, 7, 8. So empty set 0, 1, 2. Then you have 0, 1. You have 0, 2. You have 1, 2. You have 0, 1, 2. Then let's talk about operations of set. Operations, where you have the union, intersection, complement, etc. Now, union of sets, we are talking about bringing the two elements together. I'll refer to this one as addition, but you're not really adding it. You're really listing them. No repetition. So a union of two sets, A and B, is a collection of all objects that are in either set. That is, it's written as A union B. AUB. So AUB is equals to X such that X a member of A or X a member of B. So what we are trying to say here is that you bring the two sets together, marry them together, but don't add them. Marry them together, don't repeat any number, marry them together. That gives you the union of sets. For example, A is 1, 2, 3, B is 1, 3, 5, and C is 2, 3, 4, 5. What's A union B? Look at A here, 1, 2, 3, and B is what? 1, 3, 5. So their union will be 1, 2, 3, 5. 1, 2, 3, 5. That's their union. And A union C, A is 1, 2, 3, C is 2, 3, 4, 5. If you marry them together, their union is 1, 2, 3, 4, 5. Then B union C, you can see B here. B is 1, 3, 5, and C is 2, 3, 4, 5. Marrying them together, you have 1, 2, 3, 4, 5. So you are not repeating any number at all. So union, when we say union, marriage. Talk about marriage. Bringing the two together. Intersection of sets. Intersection means the common element between the two. You look at set A, look at set B. which element that is common between the two. You pick that element. That element is called the intersection of the two sets. So, for example, we have A is equals to 1, 2, 5, B is equals to 1, 2, 3, 4, 5, and C is equals to 2, 3, 4, 5. What is common between these three sets? You can see 1 here in A and in B, but it's not in C. If you want to take A intersection B now, A intersection B, if you see A, look at B, 1 is here, 1 is here, is a common element. 2 is here and 2 is also here, it's also a common element. And 5 is here, 5 is equally here, it's also a common element. So A intersection B, you have 1, 2, 5. 4 is not a common element since we cannot find 4 in A. And we cannot find 3 also in A. That is why 3 and 4 are not intersection of the two elements and two sets. A intersection C, A intersection C. You have 2 that is common here, is also in C. 5 also is in A, is also in C. So you have 2 and 5. A intersection C is what? 2, 5. Then B intersection C. B intersection C, we have 2 is here and 2 equals here. 3 is here, 3 is also here. 4 is in B, 4 is also in C, and 5 is in B, 5 in C. So this is a common element. B intersection C, we have 2, 3, 4, 5. So class, what is the intersection between the three sets A, B, C? That's your assignment. Drop your comment. Let me have your comment. Tell me what's the intersection between the three A, B, C. Looking forward to see your reply. Complement of sets. The complement of a set A is a collection of objects in the universal set that are not in A. So what we're trying to say here is that complement means if you have set A, you have set A and a universal set. The universal set is a bigger set. They have a small set, which is set A. You look at what is not in A, but it's in the universal set. That's what we call the complement of a set. Pick those elements that are not in A, but the universal set is the complement of a set. For example, we have the universal set be the integer. Let the universal set be the integers. Then the complement of the even integers. What are these even integers? We have 2, 4, 6, 8, 10, 12, and so on. What will be the complement of the even numbers? Is the odd numbers. That's 1, 3, 5, 7, and so on. Then, example 2, let the universal set be A, B, C, D, E. Then A be equals to A, B, C. What is the complement of A? If you check, you see that you find out that D and E are not in A, but you can find them in the universal set. So DE is a complement of this set. Now, difference of two sets. We're talking about difference now, minus. The difference of set A and B is a collection of objects in A that are not in B. The difference is written as A minus B. So, in set builder notation, we have X such that X is a member of A intersection T complement. Or we can say X such that X is a member of A, difference X is not a member of B. Venn diagram. What is the Venn diagram? It's a way of depicting the relationship between sets. In other words, it is the pictorial representation of sets. How you represent your set, just like a diagram, as the name implies, Venn diagram. Each set is shown as a cycle overlap if the sets intersect. This is how we illustrate a Venn diagram in a rectangular shape. Then we have a cycle inside a rectangular shape. This is one cycle, call this one set A, and this is what? Set B. They overlap each other. The middle term there that is overlapped, we call it the common term there. We can call it intersection of set, or the common elements. The common element between A and B. And it is shaded. A intersection B is shaded green. And the second diagram we have, this one has intersect, everything is overlapped. All what is shaded here completely, we add everything together, just like marrying them together. We said A union B. A union B is shaded. And the next one, look at set A, the white spot. There's no green inside, and we have the green outside. What is outside here are the complement of A. What is shaded outside? Complement of A. And then we have this set completely white. It's not colored. You can see the cycle independent. We call this one disjoint. They are not joined together. So that disjoint set. And then this is what we call the difference of set. You can see the A is shaded. Only A. We didn't shade the overlap. We are saying that only A that is shaded is what we call the difference of two sets. Elements that are in A alone, only A are shaded. Now, let's see this example here. Two sets, A and B, are divided into four parts, as shown in this figure below. X1, X2, X3, X4. Each part denotes a specific number of elements. The diagram here, number of A, you can see A here. Look at the cycle of A here. X1, X2, can you see now? X1, X2, X1, X2. X1 plus X2 is a number of A. This N here is defined as number of A. And then number of B, we have 2 plus 3. Can you see? 2 and 3. And then number of A intersection B. Number of A intersection B is equals to X2, which is this one here in the middle. A intersection B is X2. And the number of A union B, their union, everything together, X1 plus X2 plus X3. And the number of the universal set, the whole of this is universal set. X1, X2, X3, X4, everything inclusive. These are all these ones are members of the universal set. This implies that number of A plus number of B is equals to number of A intersection B plus number of A union B. Let's see one of the word problems in a set. Example 1. The head of department wishes to know the number of students that registered the course A and B in the department. Discovered that out of these 500 students in the department, 50 registered for course A, 120 for course B, and 30 for both A and B. The question is, use the Venn diagram to find how many students register for course A or course B. 2. How many students did not register any of the two courses at all? So in this case, we have number of A, which is given as 50, number of B, which is given as 120, and their intersection is given as 30, and the whole of the universal set is given as 500. So representing the information in a Venn diagram, the whole of this Venn diagram is 500. Everything here is 500. So number of A, their intersection is 30. Can you see here? Number of A intersection B is 30. But since we said number of A, the whole of A is supposed to be 50. So what will be left here? If the whole of A is 50, so if you have 50 minus this 30 will give you 20 for A alone. And then for B alone, we are giving us 120. But the intersection is 30. Excuse me, class. The intersection is 30. So 120 minus 30, we have number of students 90 for B alone. So if you add everything together, we want to know how many students did not take any course at all. So number of A union B is equals to number of A plus number of B plus number of A intersection B. So we add everything that is here, 20 plus 30 plus 90, we are having what? 140. And then that's how many students register for course A or course B. We are talking about their union. The union of the whole of this total. 20 plus 30 plus 90, that gives us 140. And then how many students did not register any of the two courses at all? You have, excuse me, you have A union B complement. Since you have A union B, number of students that register all courses, both A and B, 140. So number of students that did not register any course at all will be their complement, their opposite, which is the universal set minus the number of students that offer course A and B. So number of the universal set is 500, and number of A union B is equals to 140. So 500 minus 140 equals to 360. This transition represents those people that have not registered any course at all. This is exercise, class. Take this one as your exercise. You do it and submit next week. It's your first exercise. I'll call it as an assignment, please, class. Do it and submit it tomorrow. Next week, please. Next week, today is what? Today is Tuesday, right? Good. Next Tuesday, please submit it. Next Tuesday. Suppose that we have the set U equals to n, so that 0 is less than or equals to n and less than or equals to 1000 of the whole numbers as our universal set. Let P be the prime numbers in U. Let E be the even numbers in U. And let F be equals to 1, 2, 3, 4, 5, 8, 13, 21, 34, 55, 89. Describe the following sets either by listing them or carefully English. What is this? Describe the following sets either by listing them. 1, 2, 3, 4, 5. So E complement P intersection F, P intersection E, F intersection E union F intersection E complement, and F union F complement. And also construct a Venn diagram for the following sets: B minus A complement intersection B, A difference of B, A difference of B complement, A complement union B complement, and A intersection B complement. So merge them together with this one as part of your assignment. So see you next week. Thank you.